right, today we're going to be working on 3.3 using ratio tables. Our standard is 6th grade number sense A. Your objective is that you will be able to use ratio tables to represent equivalent ratios to solve ratio problems. Mathematical literacy, we have ratio, equivalent ratios, rate, unit rate, and equivalent rates. Let's go ahead and get started. Okay, so for 3.3 using ratio tables, our success criteria is that we're going to be able to use various operations to create tables of equivalent ratios. We're also going to be using ratio tables to solve ratio problems, and we're going to be using ratio tables to compare other ratios. All right, so for our mathematical literacy, what I mean by that is our vocabulary words. We have equivalent ratios, ratio table, double number lines. Now for equivalent ratios, the word equivalent means to have the same value. Ratios, we're comparing two different quantities, so in reality, we're comparing two quantities that are having the same value. For a ratio table, it's a structured list of equivalent ratios. For an example, if we have a ratio table like, let's say, 1 to 2, so a ratio table would be 2 to 4, 3 to let's say 6, 4 to 8. So basically what happens is it doubles, okay? So we multiply 2 times 2 and 1 times 2. When it goes here, we're multiplying 2 times 3 and 1 times 3. When we go here, we're multiplying 1 times 4 and 2 times 4. So you see that pattern develop. And again, this is a ratio table. Sometimes it gets fancy where you do have some sort of a box around it. Okay, but in all the same, it's just a ratio table. Now for a double number line. Double number line basically shows the quantity of each corresponding pair of values that line up. Again, it's just another way of saying we're doing a ratio table. So a double number line kind of looks like this. Okay, that's kind of like the x-axis there, but you have two corresponding x axes. Now, let's say that this is 0. Okay, both of these are 0, 0. And then you're going to have a value here, a value there, a value here, and a value there. Let's say that the first quantity in the ratio table is apples, and the quantity of this second ratio would be, let's say, I don't know, maybe oranges. So our ratio is 1 apple to every 2 oranges. So if we title this here apples and this one oranges, so we have 1 apple for every 2 oranges, 2 apples for every 4 oranges, 3 apples for every 6 oranges, 4 apples for every 8 oranges. Okay, so it's the same thing. A double number line and a ratio table, we're basically showing equivalent ratios, comparing two quantities that are having the same value. All right, let's go ahead and move on. Okay, so for this example, what we're going to do is we're going to make a table of equivalent ratios. So here's our situation. So we bought milk that contains 180 calories for every 2 cups. So when we make a double number line, let's make a double number line. Again, you're going to have 2 x-axes. Now, what was mentioned first was calories. So that goes in the, if this was a fraction, that would go in your numerator spot. And also that's your first quantity in the ratio. What came second was the cups of milk. So you're going to have cups down here. Now again, cups are a liquid measure. Now every starting point, let's begin at 0.
Okay, 0 calories to 0 cups of milk. So let's have this first increment, a second increment, third increment, fourth increment, and let's throw in a fifth increment, maybe a sixth one. Okay, so again, the original ratio said that we have 180 calories per 2 cups of milk. So 180 calories per 2 cups of milk. Okay, what if we have 4 cups of milk? How many calories will we have then? Well, let's see here. So basically 180 just doubles, okay? So that's going to be 360 calories for every 1 cup. What about, I'm sorry, every 4 cups. What about 1 cup? So how many cups are in one, or how many calories are in 1 cup of milk? Well, in that case, you would just divide that in half. So that would be 90 calories, okay? So, so on and so forth. So what if we have 6 cups of milk? Well, in that case, we just kind of multiply by 6. So we multiply 90 times 6. Okay, so 90 times 6 would be about, rough estimate, 540 calories. Okay, what about 8 cups of milk? And then we multiply 90 times 8 again to get 8 cups of milk. So 90 calories times 8 cups of milk, you'll have 720 calories. What about 10 cups of milk? Again, you're just multiplying the 90 calories times 10 cups of milk this time. So multiplying by 10. So 90 times 10 cups would be about 900 calories. Okay, and then of course 12 cups of milk is gonna be 12 cups times 90 calories would be, I'm guessing, 1080 calories. Okay, so basically it's all the same thing. You're multiplying both values in this double number line. So that's kind of basically it. So what you want to get is a unit ratio. The unit ratio is basically how many calories are in 1 cup of milk. Okay, so you want to get the base ratio or the unit ratio. All right, unit means 1. So 1 cup of milk has 90 calories. And then you just multiply that 90 calories times however many cups that you're going to be trying to find the amount of calories. Now here on the bottom right, I have this little asterisk here, and it reads, how can you use the double number line to find the number of calories in 3 cups of milk? So right here, 1 cup, 2 cups, 3 cups of milk. So again, for 3 cups of milk, the base value, the unit ratio is 90 calories per 1 cup of milk. Okay, so in that case, if you're trying to find 3 cups of milk, you just multiply 90 times 3. 3 times 0 is 0. 9 times 3 is 9. 18, 27. So this would be 270 calories for 3 cups of milk. All right. So hopefully that helped you guys out a bit more about double number lines and how we use those, and how we help show the quantities of 2 corresponding pairs of ratio values that are lined up. All right. Again, remember that equivalent ratios are basically, we're comparing 2 different quantities that have the same value, and we're keeping a structured list of these equivalent ratios. Okay, so we have another couple of examples here. What we want to do with this one is to complete the ratio tables that are partially completed. Now we have triangles and sides. So let's talk about a little bit of geometry here. So a triangle, okay, a triangle. Well, how many points does it have? How many corners does it have? It has 1, 2, 3 corners. So we call those vertices. Okay. How many edges does it have? How many sides does it have? 1, 2, 3 sides. Again, we call those edges. And how many faces does it have? A face would be that and has one face. Okay. So the triangle that we have here is a two-dimensional triangle, which has 1, 2, 3 corners, 3 vertices, 1, 2, 3 sides, which is the 3 edges, and of course 1 face. So what we really mean by sides is we're talking about the edges. Okay. A little bit of geometry there for you guys. All right, so we do have a unit ratio here. What comes first in your, I guess like the numerator is the triangles, the denominator is the sides. So we have one triangle that has 3 sides that we just saw here. So if we have 2 triangles, how many sides do we have? How many edges do we have? So if we have 3, 4, 5, 6 edges. Okay. Now if we have an object that has if we have a total of 9 sides, how many triangles do we have? So we already have 1, 2, 3, 1, 2, 3, 3 plus 3 is 6. So 7, 8, 9. So that would be 1, 2, 3 triangles. Now if we had 4 triangles, how many total edges or how many total sides do we have? We have 3 more sides, so 3, 6, 9, 12. Okay, so all we did here was basically add 1 more. So we're adding plus 1, plus 1, plus 1. Okay, here we're adding plus 3, plus 3, plus 3, because triangles do have 3 sides, and we're adding 1 more triangle for the top value. All right, so hopefully that helps you guys out. And remember, mathematics, if you love solving puzzles, it's all about finding patterns, and have fun with it, guys. Now down below is another example, but this time we're comparing frogs to toads. Okay, frogs is mentioned first, so that's your first quantity. To toads, it's going to be your second quantity. Now here we're going to be looking at this pattern. So looking here, if we multiply 4 times 5, that's going to equal 20. Okay. Now we're gonna have to multiply 6 times 5, and we're gonna get 30. All right. Well, if we multiply like let's say 6 times, let's see here. If we multiply that 3 more times, 30 times 3, we're going to get 90. So if we multiply 20 times 3, we're going to get 60. Okay, you see that? So 90 here. So we multiply 90 times 2, we're going to get 180. If we multiply 60 times 2, we're going to get 120. Now again, all of these are equivalent ratios. So 4 to 6 is equivalent to 20 to 30. That's equivalent to 60 to 90. And that's equivalent to 120 frogs to 180 toads. So again, these are all equivalent ratios in this ratio table. Same thing up above. We have 1 triangle to 3 edges or 3 sides. So we have 2 triangles to 6 edges or 6 sides. 3 triangles to 9 sides. And that's equivalent to 4 triangles to 12 sides. Again, these are also equivalent ratios because they compare 2 quantities that have the same value. Okay, same thing for the frogs to toads. You have 2 quantities that compare the same values. So these are all of equal measure. Now, if you have 4 to 12, you can reduce it all the way down to 1/3. 120 over 180. Again, you can reduce it even further. Okay, for an example, half of 4 is 2, half of 6 is 3. All right, so this would be, I would say, the most reduced form. 2/3 is equivalent to 120 over 180. All right, well, I hope this helps you guys out. I really hope that this makes sense to you guys. And if you need to, please rewatch the video. Again, by now you should be able to use various operations like multiplication and division to create tables of equivalent ratios, and use ratio tables to solve ratio problems, and also to use ratio tables to compare ratios. Again, you guys have my phone number. Reach out, send me a text message to my work phone, and we can meet and help you guys further. But during class, please ask questions. Let me know what you need help with. We'll talk to you later. I hope you enjoyed the tutorial. Thank you.